All right, guys, this video is on categorical variables. And there's a couple of things we need to kind of keep in mind. First of all, we talked earlier of quantitative versus qualitative data. And quantitative is pretty much just as you would think. This is numbers. And this is where numbers take on values in a true numerical sense. So, your ACT, your height, the weight of your car, your miles per gallon, things where a number would make sense in terms of measuring or counting something. Qualitative data, on the other hand, is categorical variables. And the reason I make the distinction over here about numbers taking on some numerical sense is sometimes categorical variables can be numbers. For example, the zip code for Portsmouth is 45662. That's clearly a number, but it doesn't represent anything in a true numerical sense in terms of that being a measurement or a count. It's just a location on the map that's provided by a number. So sometimes that happens, but most of the time we focus on qualitative data or categorical data as being things like gender, political party, religious affiliation, and your favorite sports team. Okay, University of Kentucky for me, Ohio State probably for most of you. But what I want to do in this video is just explain to you, or at least demonstrate for you, how we handle statistically describing this kind of information. Now, again, what do we do over here for quantitative? Well, we have numbers. We have certain summaries. And the summaries that we've looked at so far, the mean and the median and the mode and standard deviation and variance and IQR and things like that. And we also have graphs. And the graphs that apply for quantitative variables are histograms and box plots. Well, guys, when we get into qualitative variables, clearly means and medians don't apply because they require you to, for example, a mean requires you to be able to add up the responses. Well, there's no way to add up things that are expressed by words. And the median requires you to be able to order things from smallest to largest. Some of you may think there's a natural ordering in political party. Maybe I do too, but I'm not going to share it with you. Possibly even religious affiliation. Most of us think that our religious affiliation is number one. And I'm not even going to go there on gender. You guys can play that game all you want to. Because I don't think there's a natural ordering, because there's not. But to be able to find the median or something of that nature, we'd have to be able to arrange things from low to high. And we can't do that with categorical data. So the game that you got to sort of think that we're playing here, I don't know if it's really a game, but you have to think, just as we've done before, there's a larger population under investigation. And what we want to do is we want to come in here and take a small segment of that called a sample. And if we have done a good job in conducting a study, then we have conducted, or I'm sorry, not conducted, but collected a random sample. So what we are assuming in this demonstration here is that we have this larger population, we've collected this random sample, and our variable is categorical. So how do we demonstrate this? How do we display? How do we talk about it? How do we, we're giving a presentation to a group of people and we've collected gender. How do we express the characteristics, relationships, and patterns with a categorical variable? Well, the first thing we have to do is we have to realize that this is actually referred to as a sample proportion. And guys, the sample proportion is given as p hat. Now, p hat is always really easy to find because p hat is just x over n. Now, n is the total sample size, and x is the count out of the sample size that has the characteristic under investigation. So x is the count, and we can think of n as the whole. Now, for example, let's say I have a class that has n equal 30 students. And it seems to me that there's more females in this class than there are males, so I just make a count. And I found that there are 18 females and there are 12 males. So the p hat, and I'm just going to put a footnote there, if you will, not a footnote, but a subscript. For p hat would be the count of the females out of the whole. And of course this can be expressed as 0.60 or 60%. Guys, it's that easy. Where we have to do all this fancy stuff with quantitative variables like finding means and medians and standard deviations and variance and so on and so forth. The beginning step of statistically describing a categorical variable is very, very, very simple. We just take the count out of the whole, and that can be expressed as a fraction. It can be expressed as a proportion, as a decimal, or it can be expressed as a percentage. Okay? So you're probably sitting there thinking there's got to be more to it. Really, there isn't. I mean, we can get fancier with it and get into different things like odds ratios and different types of things. But for right now, that's all we need to know in terms of statistically describing the numerical summary that applies to categorical data is this p hat. So guys, it's important enough to talk about the numerical summary when we have quantitative data. We need to be able to make what's called a center statement, and we can do that by looking at the mean or the median. We need to be able to make what's called a spread statement, and we can do that with the standard deviation, the variance, the IQR, the range, or the quartiles. All right? Categorical variables. Well, we don't make center and spread statements. We just make one statement, right? We make a statement about the count out of the whole. And we do that by what we call p hat, which is the count, which is represented by x, out of the whole, which is represented by n. Guys, remember this can be expressed as a decimal or a percentage. 0.32 or 32%. Okay, so guys, it's that simple. Now, the next thing I want to get into is how we do graphs, how we look at pictures of categorical data. And what I've done is I've pulled up a couple of handouts that I've given in previous examples that I think are pretty nice. Okay, so describing categorical data. Again, categorical data places an individual into one of several groups or categories. Examples of categorical data, things that we could collect on students here at Shawnee State University would be gender, political preference, religious affiliation, and ethnicity. Now, for quantitative data, as we talked about before, we use either histograms or box plots. To display categorical data, we use what's called a pie chart or a bar chart. Now, the example that I have here, let's assume that we have a really large corporation. Think, you know, I don't know, Google, Microsoft, you know, whatever. And we pull out 474 employees as a random sample. So what we could do first of all is we could come up with the frequency. And guys, I referred to that earlier as the count. So there are 363 clerical, 27 custodial, 84 managers, which gives us a total of 427. Guys, this total of 427 stands for our N, which I referred to as our whole. Now we get up here as a percent, and this 76.6 was found by taking the 363 out of the 474. So it took the count of those that were classified as clerical divided by the whole, which is 474. Now you're probably sitting there thinking, man, statistics is awful easy if it stays like this. Enjoy it while it lasts, because it's you know, it's going to get a little harder. Now, the way that I created this, it's got something called a valid percent. Sometimes when you're dealing with real life data, you have missing data. I just finished a pretty intensive grant with the occupational therapy department in Shawnee, and I was surprised how much missing data we had. So this valid percent, pretending that we live in outside the real world here, that there's no missing data, no missing information. So that would just be a place where we would come in and talk about the missing data. But I don't think we get into that much in 1500. Now the cumulative percentage starts out with the 76.6, and then it will add the 5.7. So we know that 82.3% are either custodial or clerical. And what they've done here is they put this in alphabetical order. And 100% are either manager, custodial, or clerical. So the cumulative percent, you know, isn't super interesting in this situation, but you see it happen a lot. Now, I talked about a bar chart and a pie chart. This is a bar chart. And a bar chart looks a lot like a histogram. But the difference in a bar chart and a histogram is the bars do not touch for histogram. I'm sorry, the bars do not touch for a bar chart. Sorry, I got a text and I'm distracted by the text. So, and I was trying to fold this paper. So what they've done here is they've done in this vertical axis. Let me explain this. What they've done, the vertical axis, they've done a count. Now, it doesn't always have to be a count. Sometimes you'll see these in terms of the relative frequency. So I brought up another example here in just a second. I'll show you where they put relative frequency there. But you can see that there were 363 clerical. So they make the bar go up to 363. There were 27 custodial, so they come to 27 and 84. Now, sometimes these things, if we had other information, for example, let's say we come into clerical and we see that there were 100 women and there were 263 men who were clerical. So if we have a categorical variable that is divided into another categorical variable, so we not only have the person's position, but we have it broken down across gender. Well, what you'll see a lot is called a stacked bar chart. So we could come in for women up to 100 and shade that some way. And then we could shade the other a different way. Now, a lot of times what these statistical software packages will do, like R and SPSS and SAS and all that, they'll create this for you. But this is called a stacked box plot. So you can very quickly look at this and not only compare across the groups, across the employment categories, and see that there are far more clerical in our sample than there are custodial or manager. But if you have this kind of division, and I'm just coming up with stuff now. All right, so you can just very quickly at a glance see that of the clerical, there are more males than females. Of the custodial, it's about equal. And of the manager, there would be more females. Well, I forget now which one I did. Yeah, there would be more females than males. So again, that's the purpose of a chart, is just to give you a glance, a quick glance, and get a picture so you can detect frequencies. All right, gang. The pie chart. It's called a pie chart because you start with a big circle. And every time I draw a circle, it ends up looking like an oval. So I don't do those. But you can see here that the clerical is reported as blue, the custodial is reported as green, and the manager is recorded as kind of a light brown. And what they do here is they start with a circle, and they shade the proportion of the circle that corresponds to the, in this place, the employment category. So a pie chart is built off of the percent. So if you look back here, if we want to create something built off the frequency, then we're going to report a bar chart. If we want to create something based off the percentage, then we build a pie chart. Now, granted, there are times that we kind of mix these and put the percentage as the vertical axis on a bar chart. But typically, you can think of these things as being two separated across bar and pie, depending on percent or frequency or count. Okay? So I know that 76.6%, which is a little bit over 3/4 of the circle, 3/4 is 0.75. So I would have, when I draw my my pie chart, and I never would draw one of these, I'd always let technology do it. You can see that if I came across, you can see that the part there is just a little bit bigger than that. So this right here, a straight, perfectly straight across, would be 0.75. So we've got a little bit extra because we're 76.6%. So these things are a little, they'll test you out when drawing one of these things by hand. But typically we just put our information in a statistical software package and spit this out. So I'm never going to ask you to create one of these by hand, but I will ask you to go in and maybe take a pie chart and pull out information from it. Same thing with the bar chart, or even a stacked bar chart. Okay, because actually, if I think, I'm pretty sure you have one of those on your assignment. All right, so a little bit more about categorical data. Again, some examples. Same ones. I probably should have come up with some different ones to make it interesting, but I didn't. Remember, zip code actually turns out to be a number, but this number represents kind of a holding spot, a location, if you will. So sometimes numbers can be represent categorical variables, but usually they don't. Okay. Now let's just run through this together. So the following graph is a bar chart. So bar chart, guys, what should you think? Bars do not touch. Okay? These things look like histograms, so to speak, but they don't touch. Another thing to think about a bar chart is the ordering of the axis doesn't matter. This is completely arbitrary. They decided to put this, they decided to put car driver first, car passenger, and we'll go ahead and see what this all represents in just a second. But they decided to put the ordering this way, but it didn't have to be. They could have started with foot first and bike. And typically what you would do, you'd put this in alphabetical order, but they decided not to do that, and that's that's perfectly fine. So anyway, the following graph is a bar chart. Again, bars don't touch, not like a histogram, which represents the mode of transportation that students at a large university use to arrive at a campus on a particular day. Now guys, here the vertical axis presents the relative frequency, the percentage, and not the count. And that's perfectly fine. Sometimes that happens, okay? So approximately what percentage of students arrive by bike? Well, this is awful easy because I just come over to bike and I follow the line across, and it looks like it's just a little bit above 0.1. So I'm going to say approximately 12%. Now, what if you said 11%? No big deal. We're close. Hence, approximately. Now, if you said 62%, we got a problem. But if you follow that over and get 12, 13, 11, maybe you got real fancy and called it 11.2%, which I wouldn't understand, but yeah, hey, go for it. Okay, now we're going to get into count. This is all about percentage. So we're saying if 10,000 students arrive to campus this day, how many approximately arrive by car? Well, you can see that there's two ways to arrive by car. First of all, car is a driver, which to me looks like it's about 51%. And you could arrive car as a passenger, which to me looks like about 9%. So I'm going to say that 60% approximately arrived by car. Again, either as a driver or passenger. So guys, I take the count, 10,000 times the percentage. So my approximation of this would be that approximately 6,000 students arrived by car. All right. Shape of the distribution, guys, does not apply. It's so tempting to look at that and say, well, that's a positively skewed distribution because, you know, the tail goes to the right and all that stuff that we talked about. It does not apply because the shape of the distribution does not apply for categorical variables, categorical data, because the ordering here is completely arbitrary. I could change this around and put bike first and car, you know, and make it where the tallest bar was in the center and have something bell-shaped and symmetric. But what if I put this out here and I have something negative? You know, well, you can't do that. That's too arbitrary. We don't have that situation with quantitative data. We start with the lowest numbers and get bigger. We can't just magically take 100 and put it over here in front of 1. We can't do that. We don't have that flexibility. But we do have the flexibility here to arrange the axis however we want. So shape of the distribution does not apply. Now on the back of the page, construct a pie chart. And I wish I hadn't done this because I hate doing this stuff. But oh well. I think it's going to be kind of worth it. Let me get my paper straight here to go through one of these with you. So the first thing that I would do, again, because a pie chart deals with percentage, the first thing that I would do is I would try to get the percentages. So I would go mode and percentage. So car, driver, I think we called that 50, what did we call it? I forget now, 51%, let's call it. And then car, passenger, looks like to me it's about 9%. And then to me, bike looks like it's about 11%. And bus to me looks like about 10%. And foot looks like to me it's about 14%. And looks like we got something else going here. What is that? Rollerblading? Okay. Haven't seen a lot of rollerblading at Shawnee, but maybe I'm not paying attention. I don't know. 1%. Now, this should come close to 100%. Keep in mind, because we're doing approximations, it may not. In fact, 0, 1, 2, 6. Yeah, we're off a little bit, but again, these were approximations. So, and if we had our counts, we could get this down better. But guys, if I'm going to do a pie chart, that actually wasn't a bad circle. Usually those things get pretty embarrassing. What I would do is I would come in and just lightly draw some lines here to represent 25% each. So I know that the 51% here is going to be half of the circle plus a little bit. So I'll draw that just a little bit above, and I would come in with some legend. And again, I would never do one of these by hand. It's just, I'm just running through this with you just to give you a better indication or a better understanding of, you know, how to interpret these things when you see them. All right, so that was car driver. Next thing I would look at is I would look at something that works out nicely. And what I see here is I see these two right here. Bike and foot are 25%. So I know that I can designate this part right here, this 25%, for the 14 and 11. So I'm going to draw something and cut it a little bit more than half. So I think this is bigger than that one. So I'm going to let this be my 14% and this be my 11%. And I would come in with some legend again. So so the 11 is bike and the 14% is foot. All right. Next thing I would do is I would see that the other 25% has to be comprised of these three. And it looks like the 10 and the 9, 19, 20. So, guys, I would just come in. The 1% is going to be extremely small. So this is going to be rollerblading. And then I would see that the 10%, 11% are about the same. So come in and kind of cheat there. I'm sorry, that's not right. Is it the 10% and 9%? So we call this bus. And that car passenger. Now these things look a lot better when you do them on the computer and they have fancy colors and all that stuff. But anyway, guys, that's the way these things unfold when you're given the relative frequencies in terms of percentages. So that may be the ugliest pie chart in the history of pie charts. So that's the reason that if you were going to do some sort of presentation, if you were reporting some sort of statistical results and you did have categorical variable and you had these breakdowns in terms of percentages and counts, you would use some statistical software package to create this. But again, I went through this not for the necessarily the end product of coming up with this gorgeous pie chart that would just floor everyone. I did it just to try to give you a better indication of these breakdowns when you're given a pie chart and you're asked to go in and actually make heads or tails out of what the information is telling you. So, guys, we're done with this. That's cool. Next thing, let's get into some real life data. And I got on the internet, and there's a place called Rasmussen. Now, these are brothers who report every day on what's called a daily presidential approval tracking poll, and it's actually kind of interesting what they do. I'm going to actually give them some props today, and I'll probably spend the next semester, the rest of the semester, ripping down the work that they do. And I do want you to go ahead and tell you that they're reporting on the president, and Barack Obama is our president right now. And there's no hidden agenda here. His poll today actually comes out pretty nicely. 6,600 of actually that should be 660. That was a typo. Yeah, 660 of the 1,500 likely voters were surveyed that they approved the manner in which President Obama is performing his duty as president, and 825 of those said that they disapproved with the manner in which President Obama is performing his duties. So, I'm not here to bash Obama. You can make up your mind on that one. I'm not here to defend him. You can also make up your mind on that. I always thought it was pretty tacky when college professors tried to promote a political agenda, and I'm not going to do that to you. In fact, I'll tell you a little story. I had a student who had me in 5 classes. She's since gone on to Ohio State University and got a PhD in statistics. And I talked about politics a lot, and so finally she just, I forget whether she came to my office or stopped me after class, but she's like, okay, Darbro, I got to know, are you a Democrat or Republican? She's like, I've had you in like 5 classes, and I still have no idea. And to this day, she still has no idea, because I'm not going to tell you. That's why they put a curtain on the voting booth. But anyway, so and I will tell you that the President Obama's approval index is negative. More people think that he's doing, I would say, disapprove of the job than approve. But this is the same thing for Clinton. This happened with both Bushes. It happened with President Reagan. So it's consistent, and it's not that I'm just bringing this up because of I've got some underlying agenda here. I don't have that. So anyway, so let's just go through this together and talk about this. What is the population under investigation? Well, the sample was taken of 1,500 likely voters. So our population under study would be, would be likely voters in the U.S. So we think about all likely voters in the U.S., right? And what they've done is they've come in and their whole here, their total count is 1,500. Now, can you make a generalization for all likely voters in the U.S., which would be millions, based on only 1,500? Most people will say no. I say yes. You can actually, if this is a random sample and collected well, actually you can make a very, very, very good estimation of all likely voters. But more about that later, okay? Even though the results are presented in numbers, 660, 1,500, 825, why is this categorical data? Well, the question is, do you approve? And the response is either you do or you don't. So it's categorical because the response is, yes or no. What is the sample proportion P hat of those who approve of the manner in which Obama is performing his duties? So guys, remember p hat is x over n. So we're focusing on those who approve, and we said those who approve were 660 out of 1,500. And guys, I'll have to get my calculator on that one. I think it's 0.44. Yeah, which is 0.44 if you like decimals, or 44% if you like percentages. If you like fractions, it's 660 over 1,500. I prefer percentages. I think that most naturally rolls off the tongue. But you know, it's fine. If you like decimals, 0.44. If you like fractions, 660 out of 1,500. The daily presidential approval index is calculated by subtracting the percentage of likely voters who disapprove from the percentage of likely voters who approve. Well, we know the percentage who approve is 44%, and there were 825 out of the 1,500, which is 55%. So Obama's presidential approval index is negative, which means that there's more people who disapprove, or at least, you know, a higher percentage of who disapprove than actually approve. Now, again, don't get all, you know, bent out of shape if you're like an extreme liberal and, you know, a Democrat, and you think that Obama's the greatest thing since sliced bread. I'm not picking on him. This is consistent. President Bush, the president before Obama, his was worse than this at that time. So guys, again, it's very neutral here. I'm just telling you what the numbers say. Now, speaking of, what do the numbers say? What can you conclude from your result in Part D? My feeling is nothing to somewhere between nothing and very little. Let me tell you what's wrong with what Rasmussen does. It's going to be really cool, you guys taking this class during a time when there's or if you are, I'll probably reuse this video, but if you're taking this class at a time where there's a presidential election going on, or some sort of you know, any kind of election, it's really cool because we can draw from those things and talk about them in class. But really, you can't conclude a lot here. First of all, these 1,500 people weren't randomly selected. They have kind of a wacky selection process. So with this 1,500 not being randomly selected, it's hard to generalize to your larger population. So that's problem number one. They collect their data using telephone surveys and internet polls. And to me, that's just too much dependent on people willing or unwilling to participate in this poll. People who are typically willing to participate in these polls typically have stronger feelings than people like me. If they called me and asked me to participate in this, I'd probably hang up on them because I just would. Okay, but some people who have strong feelings one way or the other may be more tempted to participate. And I don't know, that may not be the case. But you know, I think I can draw a little bit from this. It does seem that I would generalize that Obama's presidential approval index is negative. I'm not going to buy into this 11% because I'm not going to buy into these 44 and 55. The last thing I want you to conclude is that 11% of likely voters in the U.S. disapprove versus approved. Guys, the only thing that we can say for sure is that these numbers apply only to these 1,500 people. When you start generalizing something from 1,500 people to an entire population, you got to be careful. And guys, that's something that when we get into the last third of the class, you're going to learn a lot about. So, and what a lot of people will do is they'll run downtown, have coffee with their buddies, and say, "Yeah, I saw a report on the internet this morning that showed that people in the U.S. don't like Obama." Well, that may be true, but the only thing I can get from this Rasmussen report is that 55% of these 1,500 people disapprove, and 44% of these 1,500 people approve. I'm not willing to generalize to all U.S. voters until I get, well, I should say you're not going to be able to do that until you get more statistical jargon and techniques under your belt. So, guys, I think that's it. Hopefully, after this video, you know more about categorical data than you did before you started. Remember categorical variables. Let's say we wanted to do favorite NCAA football team. And we're in a class of 50 students. And we collect some data. And we find that 40 of these, Ohio State, which would probably be about right. 8 of these, UK. And 2 of these, other. One thing we could do is we could create a bar chart. We could set this up either as a frequency or a count. I'm going to set it up as a count. 40 is my biggest. There's no natural ordering. Bars don't touch. And this chart tells us that pretty much what we knew right up here, that most students would be Ohio State fans in football. Now, I kind of think if we were doing this in basketball season that the results would be different. Corresponding with this, we can go a circle. So guys, to do that, we need percentages. So 40 out of 50 is 80%. 8 out of 50 is 16%. And 2 out of 50 is 4%. So gang, I can draw those light lines and draw my circle into, divide my circle into 25%. So I know 3 of these is going to be 75%. I need more than that. So Ohio State, of the remaining 20%, most of that's going to be UK. And this is the other schools. Okay, so guys, that's about it. That's as complicated as I want categorical, describing categorical variables. That's about as exciting and complicated as I want it to get right now. So, guys, have a good one.